Hey guys, Quiv the Lazy Geek here, and today we're going to talk about SkyWatcher mounts for astrophotography and how you can connect and control them in an efficient way. Now, SkyWatcher mounts, there's tons of ways to control them that are official, meaning that if your mount has Wi-Fi, like this one, or if you're using a Wi-Fi adapter like this one, you can use the SynScan application on your phone or on your computer, and then you can connect to that SynScan application from the ASCOM driver that is provided by SkyWatcher. So this is one way to actually control your mount wirelessly. And one of the big advantages of controlling your mount from your computer is that, of course, you can tell it to slew where you want to go via the computer. The computer can also do auto-centering of objects using a technology called plate solving. And another thing is you can connect to the mount directly to send guide pulses if you're doing auto guiding, instead of having from your guide cam to the mount using an auto guide port with an ST4 cable, which is horrible and you don't want to do it if you can avoid it. I'm not going to go into the details here, but seriously, so many disadvantages to doing that. Instead, you can connect to the mount directly and send the guide pulses directly to the mount rather than having to go through the camera. So there are ways to do that just with like Wi-Fi, or you can do the same thing with your SkyWatcher controller, SynScan controller. You can connect via the ports here, whether you have a USB port or you use those RJ45, whatever the format is. Ooh, it's stormy outside. Port, and you can connect to the mount directly and do everything that I just mentioned, which is control the mount, slew it, auto-center it, and also send guide pulses to it. So you have the whole control over the mount. Now there is another method, and this is what I have right now connected to the mount, is this little cable there, which is what is called an EQ direct cable. Now the EQ direct cable is basically used instead of the hand controller. So you would unplug your hand controller and then just plug in the EQ direct cable in there. Now EQ direct cables, you can make them yourself, or you can order them from a variety of shops, even AliExpress, although I've been told that the quality of the cables on AliExpress is bad, and some of them can even damage your mount. So you probably want to get from a well-known place. This particular cable, and this is a typical example of do as I say, not as I do, is totally bought from AliExpress, and it does work perfectly. But I am told it is dangerous, but it does work fine. Another way, so that's basically you connect directly to the mount. You don't need a hand controller, and you don't need to use Wi-Fi, which can be a bit unreliable from time to time, right? You could have some dropped packets. So this, I have a USB cable, and this replaces the hand controller. Another possibility, if you have a mount with an integrated USB port, you can connect to the USB port and using a normal USB like printer kind of cable and connect it to your computer. Once you've done that, so basically once you've managed to connect your mount using either an EQ direct cable for your specific mount, so this cable is for the AZ-GTi, there are slightly different plug types here. This is RJ11, and I believe for other SkyWatcher mounts it's typically RJ45. Don't take my word on it, just double check it. Once you've connected your mount, whether via this cable, this kind of EQ direct cable, or via the USB port that is directly on your mount, you can control the mount using several methods, and two that I know of are EQMOD and GreenSwamp Server, or GSS. And they're both ways that provide a bit more functionality than the default SynScan driver does, and you can really like fine-tune the control of your mount and do permanent periodic error correction, for example. I won't go into that in this video, but just so you have an overview of how both of those solutions work. Now, I'm a long-time user of EQASCOM or EQMOD, and I've started recently using GreenSwamp Server. I stopped because I had some guiding issues with it. I wanted to use the full moon to test out the guiding a bit more using GreenSwamp Server. Unfortunately, it's been cloudy and rainy for the past few days. So yeah, that had to be put on hold. But both solutions are available, and I'm going to talk about both of the solutions now. Okay, so both EQASCOM and GSS are available for download for free. So I will be putting links in the description down below, but you can see I am on the page of EQMOD, and you have the downloads tab here. And I have also the page of GreenSwamp Software, and you have download GSS Server that's available here. It's open source software. Now, once you have downloaded and installed the programs, either of those, or both if you want to try them one by one, you need to actually use that program to connect to the mount. So if I were to, for that I typically would open something like Nina or Sequence Generator Pro or MaxMDL or SharpCap or anything that you use to control your mount. I personally use Nina because it's free and it's open source, and I've contributed code to it in the past, and it works great for me. And what you want to do is you would have, after you've installed the driver for EQASCOM or for GSS or for both, you'll have access to EQASCOM HEQ5/6 for EQASCOM and ASCOM GSS Sky Telescope for GreenSwamp Server. We're going to start with EQMOD. So if I set EQMOD and I click on the settings icon, typically you have a settings icon for any ASCOM, for any program that connects to an ASCOM driver, and you can see that you have several kind of possibilities. Now, the first things first is under the mount options, you'll want to select auto detect for most mounts, because unlike the name suggests, it works with a variety of mounts. It works with my AZ-GTi, it works with my EQ6R, it works with my AZ-GTi, it works with basically almost any SkyWatcher mount. You can double check on their website. You have an EQMOD prerequisites page where you can look at all of the mounts that are available. And in particular, you have some specific instructions for the AZ-EQ5GT mount and the AZ-GTi mount. And for those mounts, instead of using auto detect, you'll want to go into custom, click on that wrench icon, and in there you will want to set, so for me, I would need to set for the AZ-GTi this number of steps on both RA and declination, and this number of worm steps in here, right? So I'm just copy pasting from the page. This is the mount setup. For me, it's a bit special because I'm using the AZ-GTi. Most of the mounts are fine with auto detect. Something else you'll want to configure is the COM port. And to check the COM port that you're connected to the mount, you'll have to go to the device manager. So I like to press the Windows button, type device, and then press enter will open up the device manager. And under the device manager, you will have access to COM ports, like we have here, and you can see that I have, once it reloads, two COM ports that are serial over Bluetooth. So this is not for me because I'm not connecting to this mount via Bluetooth. And I have another one that's called COM12. We want to remember COM12, and it is basically the port assigned to this particular cable. Now you have other piece of equipment attached to your computer, whether it's like an autofocuser or a filter wheel. You might see more COM ports in there, so you might have to try multiple COM ports one after the other until you find the right one. It's also if you're using the direct, if you have a USB port directly on your SkyWatcher mount and you're using that directly, you will need to find the COM port that's called prolific. So once you have prolific, that's the COM port you'll want to use. But here we can see it's COM12, so I'll go inside here and say COM12, and by default I will want to leave those options at the default values, including the baud rate of 9600, except again if you're using the direct USB cable to the mount rather than this EQ direct cable. So if your mount has a USB port in there and you're connecting to that USB port directly, you will want to use the speed of 115,200 bauds. And thank you to my viewers here who actually told me about that tip. And another thing you will want to change while you're at it, you'll want to set up your coordinates. And you will want, so where you are on Earth, basically, and you will want to also set your epoch, which is a way that mounts use to understand coordinates. This is because the axis of the Earth is wiggling a little bit, so every year the actual coordinates of the stars change very slightly, and we want to keep track of that, and this is what the epoch is for. And I set J2000, and I make sure to have the same setting in my capture software, although it's kind of fine even if they don't match, because plate solving and recentering will make things work automatically. But once you have those things set, you're good to go. You can click on OK, and then you can go back to the software and connect and click on EQMOD, EQASCOM to actually connect. Depending on your software, it might tell you that your coordinates are slightly different, so you may want to try to harmonize them between the capture software and the mount, but you don't have to if they're very close or so close as to be identical. So now I have EQMOD connected, so I'm connected directly to the mount, meaning that if I can unpark the mount, right, and I can slew the mount. So if I press this button here, I will actually be moving the mount, right? So I can slew the mount, I can make it go to some coordinates. So let's say I want to go to target this, wherever this would be, click slew, and now the mount will be slewing there. I can stop the mount if I want, so I'm controlling everything from the computer directly using this cable rather than having to go through Wi-Fi or through a port on a hand controller. And a hand controller that's dangling from your tripod, it's a great way to get more vibration and more sensitivity to wind, which is not great. So that's why I like to bypass this particular controller. Now, one thing that is very important with EQMOD is that, well, you can set the tracking right, so you can stop the tracking anytime you want, or you can set it to solar, comet tracking, custom object tracking, lunar or stellar tracking. You can also move directly from the slew controls in the EQMOD interface as well. And you have tons of options on the right that you can obtain using this button. So you have your coordinates. Very important is you have your guide settings with the guide rate, which I have set to 0.9 times sidereal guide rate. I'm not going to go into the details of guide rates today, but this is, if you're familiar with auto guiding, this is a setting that may actually be helpful. And you can also, something that's quite important in here is enabling mount limits. And if you have this available, you can also set permanent error correction. If it's available for your mount. And in this case, the mount would be basically measuring your guide pulses and basically building a curve of periodic error correction on your mount. And periodic error correction is basically your mount is never perfect, the mechanics are never perfect, so it might not track the stars at exactly the correct speed. Sometimes it slows down a bit too much, sometimes it goes a bit too fast. This is due to the mechanical elements in your mount. There's a worm gear, something called a worm gear, and even an error of a few microns on that worm gear can cause that. Permanent error correction basically measures those little changes in tracking speed and tries to compensate for them automatically, and you can do that using EQMOD. Again, I'm not going to go into details right now. This is something I'll probably do in further videos if you guys are interested in that. But just so you can see the breadth of things that are possible with EQMOD. And one of the also very important things that I really like about EQMOD is the mount limits, which you can enable and you can set. And the mount limits themselves are a bit unintuitive to set, but it is absolutely doable. And basically those limits, they're how far you want to let the mount go under the horizon or past the meridian. And especially the meridian is quite important. So if I were to take this mount and basically make it go very much east, like that, and basically the counterweight is going up and up and up and up. The counterweight bar in the end will become horizontal, and if I keep going in this direction forever, the telescope here will end up hitting the tripod, and it would be worse if my declination was a bit actually downwards, right? So we'd be hitting the tripod even more quickly. And here you can see I'm going past the horizontal, I'm almost hitting the tripod, and this is where I would be hitting the tripod. Now with this telescope, I would actually want to set a very aggressive meridian limit. But basically the mount here is tracking where I am, and you can see the green and the red icons there. If I click the plus button, it adds a meridian limit. It says that when you cross the meridian in this direction, you should not go above this or beyond this particular point here. And so that's how you can set a meridian limit in EQMOD. That lets you make sure that you're never going to hit the telescope into the tripod. And you can see here, with this particular scope, it's very easy for me to hit the tripod. So I'd likely want to set a meridian limit that would be very aggressive, like to stop it very quickly, or even I might even need a pier on that particular mount. Now I can go the other direction and do the same thing again. And you'll notice that as I slew, we have this red area that's going the other direction. It's basically saying that, hey, I am tracking your telescope. Everything is fine, right? And that's how we can see that EQMOD is indeed keeping track of what's happening here so that you can set your limits. So we're going to go completely in the other direction. We're going to make the counterweight bar horizontal in the other direction. Okay, and we've gone past the meridian, but in the other direction this time. You can see the red area is further down, so we went past meridian. And if I click plus again, that limit is updated. So now we have updated our meridian limits, which means that if the mount were to actually hit one of those limits, it would stop there, or even you can say that you want to park the mount rather than just crash the telescope into the tripod, which is very useful. You always want to have this kind of safety. That way you have several layers of safety. You have the software, the control software that tries to avoid that. And on top of that, you have the actual ASCOM driver that actively blocks such slews or blocks tracking well past the meridian. So this is very useful, and I really like EQMOD for that. So of course the interface is a bit Spartan, but there's a lot of features that are available in EQMOD. It's very old as software, but that means it's been used by many people and it's quite reliable, and I really enjoy using it. And that's one side. The other side of the software that I want to show is GreenSwamp Server. So to get to GreenSwamp Server, since I have both installed on the same machine, I'm first going to disconnect the telescope, which, since Nina was the only piece of software connected to EQMOD, makes EQMOD just go away. And instead, we're going to go inside ASCOM GSS Sky Telescope. And again, I will want to click on the settings first to make the main GreenSwamp Server interface open. And here it tells me it's already open, which is fine because we get this new icon at the bottom. And here it is. And in this here, the first time you open it, you'll want to go in those three dots here, and we'll want to set our COM port just like we did for EQMOD. We have the COM port is here, and for me, I know it is number 12 that I want to use. And the baud rate for me is 9600, but if you're using the USB plug in your mount, if yours has a USB port integrated, you can use 100,015 200 bauds. I have my observatory location here. I have all of the information that I need. And I can enable refraction, so this compensates for the position of the stars with regards to atmospheric refraction, using kind of a refraction model of the air. You can enable or disable the encoders if your mount has encoders in, like this one does, my AZ-GTi does, and you want to avoid those like the plague. You absolutely want to disable the encoders if you want high precision tracking. Those encoders might actually give almost like wrong feedback to the mount and to the driver, causing it to do something weird. So, and plus they're super low precision, so they're not really useful for astrophotography. They're only useful for pointing. So I have my encoders set to off. And you have other interesting features, which are alternate PPEC, which is permanent periodic error correction. And this is because the periodic error correction that I mentioned earlier for EQMOD, it sends guide pulses, right, to make the RA axis, the axis that actually tracks the star, speed up or slow down based on how it has measured the mount to be speeding up or slowing down, and try to compensate for that. But if you're using permanent error correction and an auto guider at the same time, the pulse guide commands from both can intersect and one can cancel the other out, and that's an issue. GreenSwamp Server has a way to actually avoid this kind of collision or actually deal with it in a bit of a smarter way than EQMOD does, and this is the alternate PPEC, which is something that you can test ideally when it's the full moon. You have another thing, which is the go-to deck pulse. This is for the declination axis, so the axis here, which typically has a lot of, or often has a bit of backlash, sometimes a lot of backlash, that is difficult to kind of counteract. And sometimes the guide pulses can take quite a long time for that axis to react. And instead of sending guide pulses, GreenSwamp servers can send go-to commands directly. So it makes the mount much more reactive, but it could be harmful to your guiding depending on your mount, or it can be beneficial to your guiding, again, depending on the mount. So this is something you want to try out. There's many things to try out with GreenSwamp Server, which is great, but which is also a pain because you don't know what's going to work and what's not going to work. There's another thing, which is the full current, whether you want to apply full current, whether you want to let the mount use like as much current as it can to slew and track around, or whether you want to be in like an economical mode. The recommendation is to keep full current to on. So you can see there's tons of options that are here, and we have Meridian limits. So this is basically the same as we did for EQASCOM, but instead of having one limit for each side, you have one limit for both sides, and you have to set the actual angle yourself. And I've set it at 10 degrees, but I can set it as low as 0 degrees to say you should stop exactly when the meridian is reached and the counterweight bar is horizontal. So a lot of things available. You have the guiding rate, which is available for both the RA axis, the declination axis, which is in percent, and ST for guide rate if your mount has a guide port and you're using like guide camera to guide port connection. You shouldn't. If you can communicate to the mount directly from your computer, you really shouldn't. But if for whatever reason you have to do that, you can set the guide rate here. And the default is 0.5. It's 0.5 in a lot of mounts. For me, I tend to have better results with a higher guiding rate, but you know, it really depends on the mount. You have the maximum speed of your mount that you can change in here, and you have minimum deck pulse and minimum RA pulse duration in milliseconds. You don't want to touch that. You don't want to touch any of those things here unless you have a good reason. You have the coordinates, but you also have the equatorial system, which is, you can have local topocentric, which is basically J now, or you have J2000. It's up to you how you set it, as long as the software that you use to actually control the mount in the end and control your capture, like Nina, is aware of what it is. And so you can see there's tons of options that are available in addition to the options that we have in EQMOD. Now, once you've set that up, you can actually click on the connect button here or the connect button in Nina. When you click the connect button here, it will actually connect to the mount from the GS server application. And when you click on connect from Nina, it will connect to the GS server application, which is responsible for connecting to the mount. GS server is named a server for a reason. It acts as a server in between the mount and the software. And here we can see we've reached an issue. Maybe some of my parameters were wrong. Okay, and I've managed to connect GreenSwamp Server to the telescope. So what we have this, it actually works the same way as ASCOM, is that we have this interface here that's connected to the mount directly, and then all other pieces of software connecting to the mount will connect through that piece of software. So if I had like PhD2 open, for example, and I wanted to connect to the mount as well, I would go into my equipment and I would say that I want to connect via GS Sky Telescope and connect. And now if I go back to this interface, you can see we have two applications connected. One is PhD2, the other is Nina. So we have our main control software and we have our guiding software that are connected to GS Server. And the first time you launch GS Server for a mount, you should launch it with the mount at its kind of like home position, like this is, because it will ask you to actually set the home position. It will pop up a message like you should set home, and you just want to click set home and accept, and now you'll be like, okay, I'm home, I'm parked, everything is good. And you can unpark the mount and you can play with the mount like this, and you can get it back home or park it again as you need. So this is very similar to EQASCOM, except it's a bit more modern in terms of an interface. Now, some of the things with GS Server is that you have the ability to add more tabs. By default, you'll just have like the SkyWatcher tab and the Options tab. And in the Options tab, you have available tabs, which are multiple. And one that I recommend is the 3D model tab. You can click here to add it, but you can also have paths that will show you like the pole locator, which is like, hey, where is Polaris in your poloscope right now? So what's the angle of Polaris, which is, pretty neat to have in any case. And you have plot and pulses. And so those plots will actually keep track of your guide pulses, for example. So I'm in PhD2 that is connected to the mount via GreenSwamp Server. I can push on north and we'll see like, okay, there's been a guide pulse in this direction, in that direction, etc., etc. Like somehow north and south gave me the same direction just now, which is a bit weird, but maybe it's simply because I haven't calibrated the guider at all with this, so it might not be exactly doing what we want. But you can see that we can actually keep track of what's happening. And I'm not sure what the plot will do. Maybe the plot will actually keep track of any slewing motion that are done. So I could go inside the plot, say start, and then I could try to slew the mount and see what happens in the plot afterwards. And yes, we can see in the plot that Ari and Deck were both moved around. So it's kind of like keeping track of the position of the telescope. But the most fun is the 3D element here, which tells me which gives me a 3D representation of where the mount is. And by right-clicking on that and dragging the mouse, I can actually change my viewpoint. So if I actually, move the mount quite a bit like this, it will tell me, the 3D representation will actually follow that, right? So once I have the mount at an angle, like here, I go back to 3D and we can see it is far more at an angle than it used to be, which is, a pretty cool feature to look at how the mount looks like. So GreenSwamp Server is very modern, it's very new, it has a lot of good stuff. I had trouble with it. One of the things when you use GreenSwamp Server, which you need to set if you're using PhD2, is in the brain of PhD2, you want to go inside guiding and you want to set the reverse deck output after Meridian flip to check. You want to check this. Otherwise, the guiding will fail after Meridian flip. So this is something to keep in mind when you're using GreenSwamp Server. Now I had some guiding issues with GreenSwamp Server recently, I mentioned it, so I want to check that again because it worked very well for a couple of nights and then suddenly I had terrible guiding. Maybe I changed something, I need to figure it out. But otherwise, it's a really nice piece of software that I want to try some more. It has a lot of potential for periodic error correction and for the guiding using go-to pulses rather than guide pulses. And if you're interested, by the way, in permanent error correction, I will at some point do a video on that, both using EQMOD and a GS server. Maybe I will also use some third-party software to do that, like Pen Pro, but I'll start with SkyWatcher mounts because this is what I have. And sorry this has been a pretty long video, but just introducing you to both EQMOD and GreenSwamp Server, which are two alternatives to using your hand controller with a cable that's plugged into your computer and then the standard ASCOM drivers from SkyWatcher. And I find that using either EQMOD or GreenSwamp Server gives you a lot of flexibility that is not available in the official ASCOM driver, and you get rid of the hand controller. You have direct connectivity to the PC. I really like it. I really think it is great, and it is like what many people using SkyWatcher mounts are actually doing. So I highly recommend it. And with that, that's pretty much it for this video. I hope it was useful, that you enjoyed looking at those solutions that we have for controlling SkyWatcher mounts. And you know, if you're not subscribed to this channel, but you like astronomy, astrophotography, and you like tips and tricks in general about those, feel free to go down below, click on that subscribe button, click the little notification bell while you're at it. And in general, feel free to go down, click on the like button if you like this video, leave a comment, or you know, if you have any suggestion, feedback, ideas, that kind of stuff. I read all of the comments and I answer most. So with that, I hope this was interesting. Thank you so much for watching. Don't forget, whenever you can, to look up at the stars, and I'll see you next time.